Welcome back. This is part 4 of HSM tutorial, and this part we'll be looking at some of the parts, sort of unconventional in a sense, parts that differ from just sheet metal or just cutting simple tube holes or contours like we did with the drive tube or like gearbox or gussets. So this first one I'm showing you. So these are wheel hubs that we made. We made these out of a 1/4-inch billet. So this is right here. This is after the cut. So we actually cut 7 at a time. This was leftover stock from when we cut out our tubing jig. And see, so this we had to machine out all of that material there, and to do that, I used 2D Pocket. So there's a couple options you can do. You can use 2D Pocket, or you can use Adaptive. Adaptive isn't quite as fast. 2D Pocket, I have about 90% tool engagement, which means 90% of the time the tool is actually cutting something. When I'm doing Adaptive, depending on how far it's cutting, sometimes you only have about 50% tool engagement, which is really slow. So I'll show you. So this is a quick simulation of 2D contour, of 2D Pocket, I mean. So because it's 2D contour doesn't work here because I need to clear out the actual area. So this sort of spirals inward toward the center there, and then it keeps cutting in circles there. So there's a couple things you want to note about this. Typically, before we used ramping to go in, but for this one, I actually use helixing. So as I mentioned before, you never want to plunge straight in. Since helixing is a way to go straight up and down in a sense, but not hurt the end mill at all, because it goes sort of it spirals down, which engages the end mill, the end mill on the side, and not the end mill straight up and down. So you see it spirals in. And the next thing you want to take a look at is for the actual job. Typically, when you select the models, it'll just create the stock, the smallest possible stock around it. But in this case, I needed to model my entire stock so that the CNC knew exactly how much stock I had. And to do that, I first made a sketch here, and this is I set that corner as my 0. So if you have it up here, I set essentially like this area over here as my 0, and then for the job to recognize the stock, I did stock from extruded sketch. So that sketch I made previously, I extruded it down to this edge. It was half inch thick stock, and so that allows CNC knows exactly how much stock I have and where it is. And so the next one, to clear out the hex here. So there's a couple ways to do this. We do have a broacher, and we can broach hex, and so we would need a 1/2-inch diameter hole. But I discovered that since we use thunder hex on all of our shafts, we can actually mill out the thunder hex and entirely skip the broaching process entirely, which saves us quite a bit of time. And so you can watch the process to simulate it. So I use the 2D Pocket here to do this. Just coming in, helixing in. So helixing in. To do that, it's pretty much the same settings as you would use with ramping. Let me just show you the settings for it. Right here, the settings for it. There's a ton of different numbers, but the one you want to keep an eye on is the ramp clearance height, which is the height you want to start helixing in at. For the ramping, we usually use about 20 thou here. Cut a little short since helixing takes a bit more time, so because it has to cover more, goes a bit more distance. So I used 15 thou above the stock. So yeah, and another thing you want to, so for the hex, pretty simple, goes all the way down, cuts that entire hex, thunder hex. and the shaft goes right through, fits perfectly. And with this pocket, one of the things we discovered on our first try of these is that it actually, if you do 2D pocket and you just select this edge right here, it will only cut to that edge. And so what was happening is it was leaving this sort of foil there, because I cut out this edge first, right? And then I cut out the outline of it. And then I end up having this really thin sort of perimeter around it, which is really sharp, and we would have to manually turn that outside down on the lathe, which takes up time. And so what I did was, instead of having the end mill cut to here, I made a sketch and drew a circle slightly larger than it, and so I had the end mill cut extra around, so that when I ended up using 2D contour to cut out this right here, it sort of overlapped cutting, so that there was no this sort of thin foil left over. And so 2D pocket, if I just selected this outside as well, it would cut out this inside, but so you have to select, so for this you would have to select 2 parameters. So I selected this parameter, and then I wanted to cut outside of that, and then this circle, and I wanted to cut inside of that, so that it got rid of this entire space in between. And for this really thick, so multiple depths, I did 0.1 inch steps at a time. And then after, so I cleared out that area first, and then I used the drill. So for this one, the drill, I can go center drill first, of course, as always. I could actually go straight down to here, wrap it down, and then make my marks on the final sort of surface, I guess you could call it, because this area was already fully cleared out. And then I used the 3/16 drill through, and then screw all these down. And then final step is the 2D contour that goes around. Same settings as usual. I did around, I believe 0.1 inch, just over 0.1 inch steps, because I needed to make sure this cut all the way through to the bottom. So I used multiple depths. I set my bottom to be 30 thou under, and then I did ramping as usual, because plunging is bad. And then I also want to disable the lead out, especially because this material is so thick. If the end mill were to lead out, so cut full depth, 1/2 inch thick, straight into the stock, you would snap your end mill out. So no lead out means you just go straight up, pull straight out. So finished product is looks just like this, and here it is on a wheel, with the thunder hex fitting perfectly in it. So the next part we'll be looking at is this part right here. Now I know this is just a tube, but for this part it was a bit interesting, since this tube was actually since these were slanted. This was part of our forks that we use for double climbing, and since the edges right here, they fit right into each other, which was part of the reasons why we could save weight. I had to cut these at angles. Now, this actually made things a bit quicker, because I was able to, because I was milling the faces of these with the CNC, I didn't have to mill the length of the stock beforehand. I just had to get it somewhat close. And I'm also able to do that because this is a single operation, single job part, because there's no features on this side or this side, and the features that are on this side and this side I can do in a single, all from this one side right here. So first start off with center drill, and then drill all the way through. This part sits on parallels, so all the way through. And then I take I believe I used a 1/4 inch end mill here. Actually, it's a slightly longer one, since the 3/16 ones we use are only about 5/8 inches long. So this was a just over an inch long 1/4 inch end mill, and I use the 2D contour, and I'm able to. So I select just the edges here. And now, so one of the things you want to pay attention to is here in this model, typically we have propagate along Z and tangent propagation on, which means if I select one edge, it'll select the edges connected to it in the same plane, which I do not want there. I want only, I want it to only cut this edge, this sort of round edge there, and this edge, and I want it to cut on the outside. So we'll first take a look at the simulation. So you can see, you see that large lead-in from the side, just like that. So I don't need to actually do any ramping here. Ramping here would be kind of pointless, but I don't want to plunge straight into the material, so I go down and then I have this big arc going in, just like that. And I take quite a few steps, because there's a lot of tool engagement there. Same with over here. So just like that, curve in, curve in. And to do this, before in this right here, typically we didn't mess with these lead-in things, but I changed the radius of the lead-in, which was how large the arc was, and I set that to be pretty large, quarter inch radius, so that it would curve smoothly inward. And for the heights, I set it to be a bit lower than here, so it would cut extra, and to ensure that the part was cut all the way through. And so for this part, actually, the way it was actually cut on the CNC, the vise held the tube in the middle here for maximum stability, and then because I can't have the vise holding it here, otherwise I would cut into the vise. So when I zeroed it, I zeroed this edge. I zeroed the edge of the vise. This the X0, but then for the Y0, I sort of just estimated it around somewhere around here in the tube, because that I would be milling it off, so it didn't really matter how precise I really was, as long as I had enough tube left over to actually be milled. So the next part we'll be looking at is this. This is a tube from our carriage on our elevator. So the rest of this, so most of this is pretty simple. Is 2D contour, drilling operations. The one you want to look at is this one right here. So this one was a bit interesting. Originally I used a trace, that's why I have this here. I traced this out, but then using the trace function. But with the trace function, the issue is that you don't have very much control over like how many steps to take, or ramping and everything. So I ended up using a 2D contour. And then I had to draw a sketch for this as well, because I needed to ensure that the CNC would cut all the way through and cut in this entire gap out. So we watched the simulation for that. So I know it's typically, I know I say it's bad to plunge, but I did have to end up plunging into here. So you can see it actually cuts a little bit, it cuts extra there. Because otherwise, if I set it to cut, just this edge right here, it would leave a radius on this corner, which I don't want. I need this to be perfectly flat, and the slot cut all the way out, because the bearings sit there. Bearings on the elevator sit there. Our final part we'll be looking at is this. So this was made out of a sheet of 1-inch thick Delrin. Now this part was a bit interesting to cut. This was part of our forks. This fit inside of a tube, actually, one of the tubes on our forks, to reinforce it. Now, so I started off with a drill function that drilled through the entire stock, and just like before, actually I did not. So this one I had default stock because it didn't matter too much, but for the drilling, I drilled all the way through. Now, when you're drilling this deep, you're going to want to clear your chips, and that's what this fourth tab is for. Typically, unless you're drilling something super deep, you won't need to use it. There's called deep drilling full retract. So once it goes for a certain amount of distance down here, which you can set, it goes up to clear the chips, waits a couple seconds, and then goes down, and then goes up, and then goes down. And that allows you to drill, deeper stuff without getting all the chips and stuff clogged up. And the next function I had to use, because this was a 1-inch thick sheet of Delrin, and these needed to be 0.8 inches thick a little less actually, so that they'll fit inside of the tube. The tube is a 2x1 tube with 0.1 thick walls. So this had to be, so I had to essentially face the surface down. I used a 7/16 mil, I believe, a 3/8 inch end mill, and I faced this entire area down, and I had to actually create an extra sketch because I needed to clear out more than just the tops of these, because I wanted to cut all the way down as well. So I faced extra there. So the face tool, it's you can select select stock contours, and then so I selected the sketch that I made as the stock contours, and that's what it thought was the stock, and so it just faced the entire thing down, made it from 1 inch thick to 0.79 inches thick. We watched the simulation for that, and then you can set multiple depths as well for this. So you can't. So the stock, it was the default stock, right? So you can, it looks like it's just cutting air now, but you have to remember that this was indeed an inch thick, so it was up to here thick. So, you can see it cuts multiple layers down. It takes 4 steps to get to the final layer. And then I used just 2D contour. I used a 1/4 inch end mill, which was the longer one we have, which I used also for cutting the fork tubes that I showed previously. So it's cut all the way through for this one and for the outline. And there's the typical settings I used for contours, 30 thou extra, about 0.1 inch steps. So, yeah. And these were 4 that were in a way slightly trickier to do, since they weren't my typical just gusset on sheet metal or just tube with holes in it. And thanks for watching.